Here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, so we're starting a new chapter today and we're going to take a look at section 10.1. So here we go. All right. So we're going to look at different ways of solving second degree equations. Now, in this course, we started out in chapter 6 and we looked at solving equations of second or higher degree by factoring. We're going to be looking at some alternative methods to factoring here in this chapter. So first of all, let's take the problem x squared minus 9 equals 0. Okay. Going back to chapter 6, what we have on the left side of the equation is the difference of two squares. And we could factor that into x plus 3 times x minus 3 equals 0. And then we take x plus 3 equals 0, x minus 3 equals 0. We'd subtract 3 from both sides and get x is -3. We'd add 3 to both sides and get x is 3. So in fact, there are two solutions. X is 3 and x is -3, right? So the second degree equation has two solutions. Now, let's take this same problem and let's take a different approach. Now what we're going to do, we're going to put this problem in a form where on the left side of the equation, we have a perfect square that contains the variable. And on the right side of the equation, we're going to have a constant with no variable. So my first move here is going to be to add 9 to both sides of the equation. Now, back in chapter 9, we had equations with radicals where we would square or cube both sides. Now we're going to go the other direction. We're going to take the square root of both sides of the equation. So we get x equals 3. However, recall that there were two solutions, +3 and -3. So what we do in this case, when we take the square root of both sides, we put a plus or minus, or plus and a minus like that, to indicate both solutions, okay? This process is called the square root property, okay? Where we set it up like this, we take the square root of both sides, we attach a plus or minus to the constant side, and we get the two solutions. Now, in the regular classroom, you could write it like this. WebAssign does not accept this plus or minus symbol. So what it'll do, it'll tell you to write the separate solutions separated by a comma. So you'd write 3, -3 or -3, 3. You wouldn't write it as a plus or minus package. It doesn't have that available, at least not that I've been able to find. Okay? All right. So now let's take a look at another problem. W squared minus 47 equals 0. So again, I'm going to add, in this case, 47 to both sides of the equation. So now I have a variable squared equals a constant. I will take the square root of both sides, and I get W equals plus or minus the square root of 47. Now, 47's prime, the square root of 47 doesn't simplify. So my two answers are going to be negative the square root of 47, comma, the square root of 47. I want to point out a problem that students have had. So you need to be careful. In WebAssign, where it says separate it by a comma, what I've had students do is they'll do this. They'll go like that, and then they'll have that. And what they've done is that comma will be inside of the radical. And then WebAssign doesn't recognize that, and so it says it's wrong. So what you've got to do is you've got to make sure that you get outside of the radical before you put your comma in there, okay? So hopefully that won't be an issue if you do that correctly. Okay, moving on. Let's say we've got u squared minus 24 equals 0. So again, I'm going to isolate the perfect square that has the variable in it and separate that from the constant term. So now taking the square root of both sides of the equation, we get u equals plus or minus the square root of 24. However, the square root of 24, we can simplify. Let's see, that would be the square root of 4 times 6. So we get 2 square roots of 6. So u would be plus or minus 2 square roots of 6. So writing that in WebAssign, it would probably say u equals, and you'd put in negative 2 square roots of 6, comma, 2 square roots of 6. Any questions there?
No.
Sorry, did somebody have one?
No, I don't have any.
Everybody's good? Okay.
I didn't, thank you.
Okay. Let's see here. Now, let's say we've got this. 3x squared minus 16 equals 0. So I'm going to add 16 to both sides of the equation and get 3 squared equals 16. Now, x squared is a perfect square, but 3x squared, the 3 part of it is not. So I'm going to divide both sides by 3, and I'll get x squared equals 16 thirds. Okay, now I'm going to take the square root of both sides. So I'm going to get x equals plus or minus the square root of 16 thirds. But that would be equal to, what's the square root of 16?
4.
And then I still got the square root of 3 down below. However, back in the last chapter, we learned about rationalizing the denominator. So we're going to multiply this by the square root of 3 over the square root of 3. So x is going to be plus or minus 4 square roots of 3 over 3. Okay, so x is going to be negative 4 square roots of 3 over 3, comma, positive 4 square roots of 3 over 3. And there are our 2 solutions. Any questions there?
No.
All right, let's say we've got something like this. X minus 7, the quantity squared, equals 9. On the left side of the equation, we have a perfect square, trinomial, that has a variable. On the right side, we have a constant. Now be careful. We don't want to FOIL that out. We're going to take the square root. Okay. I mean, FOILing it out, we could solve it that way, but that's not what we're looking at today. So now I've got x minus 7 equals plus or minus 3, because the square root of 9 is 3. I'm going to add 7 to both sides of the equation. X is 7 plus or minus 3. So x is 7 plus 3, which is 10. X is 7 minus 3, which is 4. So x equals 4, comma, 10. Sometimes it'll tell you to write the solutions from smallest to largest. That's why I did it that way, but it doesn't always do that. Okay. Another problem. It says, let G of A equal the quantity 7A minus 2 squared. For what value or values of A is G of A equal to 8? So we're going to make a substitution. We're going to take 8 and put it in the place of G of A. Okay, so our equation will look like this. 7A minus 2, the quantity squared, equals 8. And I could have written 8 equals the square root, or 7A minus 2 squared, but I just like to have my perfect square with a variable over on the left side. You don't have to do it that way. Okay, so now taking the square root of both sides. Don't forget the plus or minus. We get 7a minus 2 equals plus or minus the square root of 8. I need to solve for a, and I need to simplify the radical. I'm going to go ahead and simplify the radical first. The square root of 8 is the square root of 4 times 2 is 2 square roots of 2. So this becomes 7a minus 2 equals plus or minus 2 square roots of 2. Okay. So next, I'm going to add 2 to both sides. So I've got 7a equals 2 plus or minus 2 square roots of 2. Then I'm going to divide both sides by 7. So a equals 2 plus 2 square roots of 2 over 7. Now, oops, I left out the minus. So in WebAssign, you would say a is 2 plus 2 square roots of 2 all over 7, comma, 2 minus 2 square roots of 2 all over 7. Make sure you get your plus and your minus signs in the right places. They don't go in front of that first 2, they go in between the first and second 2's. Any questions on that?
No.
Okay.
No, not for me, thank you.
All right. Well, that was kind of the warm-up exercises, actually. Now we're getting into the good stuff, so to speak. Let's say I have this. I have x squared plus 24x plus 144. All right. That is a perfect square trinomial because it would be x plus 12 times x plus 12 or x plus 12, the quantity squared. Again, how did I get there? Factoring. We could get 2 identical factors and then write it like that. So this is a perfect square. We okay with that?
Yes.
All right. Now, I want to go back here and just write this. And my goal now is to turn this into a perfect square trinomial. And here's the process, okay? If I have a leading coefficient of a 1 that's implied, what I need to do is I look at the coefficient of the first degree or linear or the x term, okay? And the coefficient is a 24, all right? I take that coefficient, I divide it by 2, I take the results and I square it, and that is the constant that will then give me a perfect square trinomial. So if this is a 1, take that number, cut it in half, square the results, and you create a perfect square trinomial. Okay, let's look at several of those till you've got the idea. Y squared minus 18y. So I have my leading coefficient of a 1. I'm going to take the coefficient of the y term, which is negative 18. I'm going to cut it in half, which is negative 9. I'm going to take the results and square it, which is 81. It's a positive 81. So y squared minus 18y plus 81 is a perfect square. And the factors are going to be y and then whatever that number is that I squared. Y minus 9 times y minus 9. You see what I'm doing there? Taking 2 terms, figuring out what to add to it to turn it into a perfect square. Any questions?
No.
All right, we'll keep going. A squared minus 7a. So here again, I'm going to take the coefficient of a, which is negative 7. I'm going to cut it in half, which is just negative 7 halves. I'm going to square it, which is 49 fourths. And I'm going to add that to make it into a perfect square. And the factors are going to be this and then whatever's there. So minus 7/2, minus 7/2, a minus 7/2, the quantity squared. So if I take that and write it like that and FOIL it out, I'll get that. If you need me to prove that to you, say so and I'll do that. Otherwise, I'll just keep going. Anybody need proof?
No.
Nope. Okay. Let's take a look at this one. X squared plus 2/3 x. Okay. So again, we want to complete the square. So my coefficient of x is 2/3, and I'm going to cut that in half. So I'm going to divide that by 2. Well, isn't that the same thing as dividing by 2? Isn't that the same thing as multiplying by 1/2? So instead of saying dividing it by 2, we could say multiply it by 1/2, which would basically be 1/3. Okay, half of 2/3 is 1/3, right?
Yes.
Now we're going to square that, which gives us 1/9. We're going to add 1/9. So that is a perfect square trinomial. And let's see, we squared 1/3. So there are the two factors, and there it is written in that form. We okay with that?
Yes.
All right, now, if we go back a ways, let's see here. Actually, what do I want? I want further down. This one. This problem, we had a perfect square set equal to a constant, right? And that was nice. We took the square root of both sides and wonderful things happened. Now we've looked at how to, create a perfect square. So let's take this situation. X squared minus 4x minus 2 equals 0. What we are going to do, we are going to manipulate this equation so that we get it in the form of a perfect square trinomial on the left side of the equation, a constant on the right side of the equation. Then we'll go through and take the square root of both sides, etc., etc. All right, now, there is a several step process. If you have the textbook, the process is outlined on page, 831. I don't know if the ebook online, if it's the same page or not, but this is again in section 10.1. And I'm going to go through all the steps, but just if you want to refer to it in the book. Okay. All right. The first thing I need to do is I need to have a +1 coefficient on my leading term, x squared. I guess actually before that, I need to have it in standard form. You know, ax squared plus bx plus c equals 0. And it is in standard form. If my leading coefficient right here is not a 1, then I would divide each term on both sides to turn it into a 1, okay? Since it is a 1, we're good to go. The next thing I'm going to do is I'm going to get the constant term that is there moved to the other side of the equation, okay? So my leading coefficient is a 1. I've moved the constant term over. Now what you see on the left looks like the problems we just went through, where we've got this and we're supposed to turn it into a perfect square. But now that it's an equation, anything that we do to the left side of the equal sign, we have to do the same thing to the right side of the equal sign. Okay, so my leading coefficient's a 1. The coefficient of x is -4. I'm going to cut that in half, and I'm going to square it, and I'm going to add 4. Adding 4 to the left turns it into a perfect square, but whatever I do to the left side of the equation, I have to do to the right side of the equation. So now what I've got is that. 2 + 4 is 6, okay? But on the left side of the equation, I now have a perfect square trinomial, which is going to be what? X minus 2, x minus 2, or x minus 2 squared equals 6. This process that I've taken you through is called completing the square. We took the equation and created a perfect square trinomial on the left side of the equation and just a constant on the right side of the equation. Before I go on and finish this problem, do you have any questions about what steps I did?
No.
All right, so my next step is going to be to take the square root of both sides. So I get x minus 2 equals plus or minus the square root of 6. I'm going to add 2 to both sides. X equals 2 plus or minus the square root of 6. I can't simplify the square root of 6 any further. Let's see. It says approximate each solution to the nearest hundredth. What I'm going to do, I'm going to take these solutions and I'm going to go to the next page. Okay, so my two exact solutions would be 2 plus the square root of 6 and 2 minus the square root of 6. To get the decimal approximations, I'm going to punch into my calculator 2 and then plus the square root of 6. So 2 plus the square root of 6 equals, and let's see, here I get 4.44948, blah, blah, blah. It said round to the nearest hundredth, which would be that place. The 9 would round up. So 4.45 would be the decimal approximation for this first answer. And then here, 2 minus the square root of 6, I would get negative 0.4494, blah, blah, blah. Again, this would round up negative 0.45. Okay. So here are the two exact solutions. Here are the two decimal approximations. Any questions about that?
No.
Just a note, if we had tried to solve this equation by factoring, it doesn't factor under integers, fractions, whatever, because of this radical. So you wouldn't be able to solve it using conventional factoring, but we can solve it this way. Okay, how are we doing for time? We've got plenty of time. Let's take another one. X squared minus 18x plus 2 equals 0. So again, I have a leading coefficient of a 1, so I don't need to worry about that. I'm going to move the constant term to the other side of the equation. Notice, and I did this in the last problem too, that I leave a gap right there. That's to put that number in that we're going to find. So I'm going to take negative 18 divided by 2, that quantity squared. So I'm going to add 81 to both sides of the equation. On the left side, I've got x minus 9 times x minus 9, or x minus 9 squared. On the right side of the equation, I've got 79. All right, so now we're ready to take the square root of both sides. Plus or minus the square root of 79. X minus 9 equals plus or minus the square root of 79. I'm going to add 9 to both sides. X equals 9 plus or minus the square root of 79. 79 is prime. I can't simplify that radical any further. So x is going to be 9 plus the square root of 79. X is 9 minus the square root of 79. And again, I'm going to go to the calculator and approximate it to the nearest hundredth. So I've got 9 plus the square root of 79. Oops, wrong number there. And I'm getting 17.888. So that would round off to 17.89. And then 0.111, which would round off to 0.11. So here are my two exact answers, and here are, or here, I guess, and then here are my decimal equivalents. All righty. How are we doing?
So far, so good.
Okay, we're going to turn up the heat just a little bit more here. Let's take a look at this problem. 2x squared minus 5x plus 2 equals 0. Actually, on a cold day like this, turning up the heat might be a good thing. We'll see. Right. So what's different about this problem is now the leading coefficient is no longer a 1. So my first step is going to be to divide everybody by that leading coefficient. So now I've got a leading coefficient of a 1. My next step is going to be to move the constant over. Okay. So step number 1, clear make the leading coefficient a 1. So divide everybody by a, think in terms of ax squared plus bx plus c. Next move, second move the constant over. Okay. Now we're going to take the coefficient of x. I'm going to cut it in half, which is like multiplying it by a half, because if you divide it by 2, multiply it by a half. Okay. Then I'm going to take that and square it and add that to both sides of the equation. When I do that, on the left side of the equation, I produce a perfect square trinomial with two identical factors. That's why it's a perfect square. And again, this number right here is what goes here and here. Now I've got to combine those two. Well, let's see. This would be like negative 16/16 plus 25/16, because negative 1, I need a common denominator of a 16. Negative 16 plus 25 is what? 9. So I've got 9/16. Okay. I'm going to recopy that on the next page. X minus 5/4 squared equals 9/16. Just give you another minute there to look at this page in case there's anything you're still writing down. Okay, so now we'll take the square root of both sides. So we get x minus 5/4 equals plus or minus 3/4, right? Because the square root of 9 is 3 and the square root of 16 is 4. Then we'll add 5/4 to both sides. So x equals 5/4 plus or minus 3/4. So x equals 5/4 plus 3/4, which is 8/4, which is 2. And x equals 5/4 minus 3/4, which is 2/4, which is 1/2. So x equals 2 and x equals 1/2. No decimal approximations needed here because the answers come out to a nice number. Any questions on this one? Okay, let's see here. How are we doing? Let's take a look at this one. 6x squared minus 12x plus 1 equals 0. It's in standard form, ax squared plus bx plus c equals 0. My leading coefficient is not a 1, so I'm going to divide each term by that leading coefficient to turn it into a 1. So I get x squared minus 2x plus 1/6 equals 0. So step number 1, if the leading coefficient is not a 1, turn it into a 1. Step number 2, move the constant term over to the other side of the equation. So I'll subtract 1/6 from both sides. x squared minus 2x equals negative 1/6. Again, I leave a space there to put the number I'm going to find next. Take the coefficient of x, cut it in half, divide it by 2, or multiply it by 1/2. Take that quantity and square it, and add it to both sides of the equation. Now, on the left side of the equation, I should have a perfect square. On the right side of the equation, I've got what? Negative 1/6 plus 6/6, which is 5/6. So I've completed the square. I'm going to take that and copy it on the next page so I have more room to work with. We good to go on?
Yes.
All right. So now take the square root of both sides. Add 1 to both sides. Okay. Now, let's see here. Hang on a second. What we're going to do now, and this perhaps is going to seem confusing. Okay. We're going to clean this up, this answer. And here's what's going to happen. Okay. So that's the same thing as x equals 1 plus or minus the square root of 5 over the square root of 6, right? We're going to rationalize the denominator. So we're going to get x equals 1 plus or minus the square root of 30 over 6. Now, they like a package deal. So we're going to write this as one single fraction, meaning so what we're going to do is we're going to have a common denominator of these two terms. I mean, this answer right here is technically correct, but I'm just looking at different forms. So I'm going to rewrite this. So this would be what? 6/6 plus or minus the square root of 30 over 6. So I've got a common denominator of a 6. So now I can write it as 6 plus or minus the square root of 30 all over 6. And that tends to be the answer you would see like in a textbook. Okay. Now, with WebAssign, we'll split those up and we'll have, I'm going to take that and write that on the next page. X equals 6 plus or minus the square root of 30 all over 6. So I've got x equals 6 plus the square root of 30 over 6. X equals 6 minus the square root of 30 over 6. Okay. Now I'm going to get decimal approximations, but before I do, any questions back here on what I did to get that into that sort of package? So I've rationalized the denominator. I've gotten common denominators between the two pieces, so I can put them all together like that. Now, when I go to put these in the calculator, I have to be careful. If I put it into the calculator like this, that's going to give me the wrong answer because that's as if though I've done that. So what I need to do is I need to let the calculator know that all of this gets divided by 6. So then all of it will get divided by 6. Okay. So what I'm going to do is this. To put this in the calculator, I'm going to start out with a left-hand parenthesis, 6 plus the square root of 30. Now, if your calculator gives you a left-hand parentheses when you put in the radical, you also have to put in a right-hand parentheses and then close up the entire numerator. If it doesn't, if it just gives it to you like that, then you would just have that one set of parentheses. But if when you push your square root button, it gives you a left-hand parentheses, you've got to close that up, but also close up the entire numerator. Okay. And we're going to go through that right now to see, make sure if you have a calculator with you, we'll see what the correct answer would be. So I've got parentheses 6 plus the square root of 30. My calculator puts in that left-hand parentheses, so now I'm going to close up the radical with the right-hand parentheses, close up the entire numerator with another right-hand parentheses, divided by 6, and I get 1.91287, etc., etc. So 1.91 to the nearest hundredth is what I would be getting. Okay, if any of you have a calculator and you're doing that now and you're having issues, let me know and we'll talk about it. Okay, the second one, we're going to do the same thing. Parentheses 6 minus the square root of, and this is going to be in parentheses, and then an entire thing divided by 6. And here I get 0.087, which would be 0.09 to the nearest hundredth. Okay with that?
Yes.
All righty. Let's see here. What are we doing? We got 14 minutes. Let's do. Let's do this one. 3/8 x squared equals 1/8 minus x. So the first thing we're going to do is get it in standard form. Actually, tell you what, let's do that. Let's do that. I'll talk about it here in a minute. So I'm going to add x and subtract 1/8. Add x and subtract 1/8. So I get 3/8 x squared plus x minus 1/8 equals 0. The reason I was hesitating is because I just moved the 1/8 up from the left or from the right side to the left side. And in a minute, I'm going to move it back again. So it seemed like, why not just leave it there? But I don't know if that's going to confuse you. So I'm just going with standard form. Okay. Now, I need my leading coefficient, which is currently 3/8, to be 1. I could go through and divide each term by 3/8, but dividing by 3/8 is the same thing as multiplying by what?
8/3.
Correct. So, okay. So 8/3 times 3/8 x squared plus 8/3 x minus 8/3 times 1/8 equals 0 times 8/3. Again, do you see by multiplying by its reciprocal, I get 1x squared plus 8/3 x minus 1/3 equals 0. Okay. Next step, I'm going to put that 1/3 back on the right side. So I've got x squared plus 8/3 x equals 1/3. Still with me?
Yes.
All right. So now I'm going to take 8/3 and cut it in half or multiply it by 1/2, which is 8/6, which is 4/3. Okay, reducing it down. Then I'm going to take the 4/3 and square it, which is 16/9. And I'm going to add that to both sides of the equation. Okay. I'm going to take all of this and recopy it on the next page. X squared plus 8/3 x plus 16/9 equals 1/3 plus 16/9. Now, on the left side of the equation, I have a perfect square. And remember, this number that gets squared is a number that goes in here. All right. And then that's going to be x plus 4/3, the quantity squared. Okay, I've got to add these two together. What's the common denominator of 3 and 9?
9.
So I'm going to multiply 1/3 by 3/3. So I get what? 19/9. Okay. So now I've completed the square. I got all of that done so that I could take the square root of both sides of the equation. So x plus 4/3 equals plus or minus the square root of 19 over the square root of 9, which is 3. Okay. Then I'm going to subtract 4/3 from both sides. X equals negative 4/3 plus or minus the square root of 19/3. This one already has the same denominator. So x is negative 4 plus or minus the square root of 19/3. So that would be the nice, neat package deal that typically you would see in a textbook. Now, for WebAssign, we would put in x equals negative 4 plus the square root of 19 all over 3, x equals negative 4 minus the square root of 19 all over 3. And then getting a decimal approximation to 2 places. Again, you have to parenthesize the entire numerator as well as the radical. So you're going to have them here and then there, here and then in there. Okay. So parentheses, negative 4 plus the square root of 19, close it up, close up the whole thing. And I'm getting, let's see here, what am I getting? 0.119. So that would be what, 0.12. And then the minus would be negative 2.786. So that would be negative 2.79. Okay. Let's see here. Where did I get that one for? There it is. All right. So things can get kind of horrendous here. The good news is tomorrow we're going to look at a nicer way to do all of this. But you got to have the broccoli before you get the chocolate cake. Okay. And when you see the chocolate cake, you might still think it's broccoli, but we'll see. We'll see. All right. So if you have any further questions, or I guess I should say, do you have any other questions right now?
No, I don't.
All right. Then I'll stop the recording.